Welcome to episode 21 of our Explainer series. Today, we're diving into a phrase that's been practically everywhere in the AI world over the last year or so: deep research. We're going to take a calm, thoughtful look at this because honestly, the implications of this concept completely shift how we view artificial intelligence and what it's actually capable of.
So first things first, what does deep research actually mean? Right off the bat, it sounds pretty straightforward, right? It just sounds like a system that searches a whole lot more thoroughly than anything we've used before.
Think about it. Instead of reading 10 web pages, maybe the system reads 1,000. Instead of summarizing a couple of documents, it analyzes hundreds of complex academic papers in literally seconds. Now, don't get me wrong, this is incredible progress, and it's super useful, but it really makes you stop and wonder, does scale alone equal true research?
Is that actually research, or is it just information retrieval on steroids? There is an absolutely crucial difference here that we need to pin down right away. Because simply collecting information, that is not the same thing as discovering knowledge.
Just imagine walking into the world's largest library. You could spend decades reading every single book on those shelves, and when you finally finished, you'd have an extraordinary amount of information crammed into your head. But would you have necessarily discovered something nobody else has ever seen? Well, no, not necessarily. You see, true research isn't measured by how much information you can consume. So, how does true research actually begin? It happens when previously disconnected ideas finally get connected. Think about it. A scientist doesn't become famous just because they read more papers than the rest of their department. They make their mark because they recognize relationships that everyone else completely overlooked. And the crazy thing is, those relationships were usually sitting there the whole time. The information was already out there, but the insight, that's what was missing.
This distinction is becoming a massive deal as AI keeps advancing. I mean, modern systems are already blowing our minds. They can summarize massive books, compare dense research papers, spot recurring themes, and spit out comprehensive reports. That is tremendously valuable, and it saves us an unbelievable amount of human effort. But at the end of the day, these capabilities are largely descriptive. They're great at organizing existing knowledge, but they rarely create genuinely new understanding.
And that's exactly the contrast we're looking at. Deep research isn't just about reading more. It's about discovering what all that existing information hasn't revealed yet. It breaks away from that simple, linear loop of searching and collecting and moves right into formulating hypotheses based on evidence to actually reach a completely new understanding.
Real research requires a whole different toolkit. We're talking about constructing hypotheses, testing those hypotheses, tossing out the weak explanations, reconciling conflicting evidence, and uncovering hidden causal structures. It's about constantly revising what you know every time a new piece of evidence pops up. Put simply, research isn't just a document processing task. It's an active, relentless loop of discovery.
This totally reframes how we should be thinking about deep research. Maybe the future isn't just an AI that reads faster and reads more. What if the future is an AI that asks better questions? Just imagine an AI asking questions that literally nobody has ever thought to ask before. Questions that point out glaring contradictions between accepted theories. Questions that expose those quiet little assumptions we all just take as fact. Questions that crack open entirely new directions for investigation. When you do that, the whole game changes. The objective isn't information retrieval anymore. The objective is knowledge generation.
Now, if we look at this through the lens of what's known as the energetic paradigm, this distinction is absolutely fundamental. Knowledge doesn't just magically appear because you piled up enough data. Knowledge emerges because limited resources are continually, actively directed toward reducing uncertainty.
Because every single action in this process comes with a very real cost. Doing an experiment, that costs time. Running a simulation, that eats up computation. Verifying data, that demands attention. And every single failed hypothesis teaches the system something crucial about where its future effort should and definitely should not be spent. A system can't just explore everything equally. It has to constantly make tough calls about where its next unit of effort will actually generate the biggest leap in understanding. It's a deeply energetic decision.
So when you look at deep research this way, you realize it's not just a supersized search engine. It's not a faster summarizer or some automated report writer. It's a system that takes charge and actively manages its own process of discovery. It's deciding on its own which questions deserve a closer look, which evidence needs verifying, which contradictions absolutely have to be resolved, and, maybe most importantly, which dead-end ideas should just be abandoned entirely.
And every piece of this puzzle serves a much higher purpose. The ultimate goal isn't just to stockpile more facts. The goal is to build a progressively more coherent, structured understanding of reality itself.
We can really boil it down to this perfectly clear lens. Information is merely the input. True understanding is the output. In that space, right in between the two, that is exactly where true intelligence lives. Which brings us to a really fascinating threshold. In our next explainer, we're going to examine another huge piece of this puzzle. Because, think about it. Once an AI system starts conducting its own true research and generating its own original knowledge, we run into a completely new challenge. How exactly does it decide which of those discoveries are important enough to remember and which ones should just be forgotten? Let's figure that out next time.